Problem 4. Let R be the region in the first quadrant enclosed by the graphs of y equals 2x and y equals x squared as shown in the figure above. Part A, find the area of A. Alright, so we see that A is just this region right here. We know to get the area of A, it's going to be point of intersection to point of intersection nicely. We can tell that it's from x equals 0 to x equals 2. And then we just need to do the top curve minus the bottom curve. In this case, if I drew my little bar, the line is on the top and the curve is on the bottom, so this is going to be 2x minus x squared dx. This is a non-calculated problem, so we do need to actually evaluate this integral. The antiderivative or anti-integral of 2x is just x squared, and then minus the antiderivative of x squared is 1/3 x cubed, and then we do have to evaluate it at 2 and at 0. When I plug in 2, I'm going to get 4 minus 8/3, and then minus, when I plug in 0, I will get 0. Make sure you do plug in 0 though, because sometimes the answer is not 0, it just does happen to be in this case. And then from here, this will be 12/3 minus 8/3, which gives us 4/3. This part of the problem was actually worth 3 points. You got 1 point for having 2x minus x squared, you got 1 point for getting x squared minus 1/3 x cubed, and then you got 1 point for getting the right answer. Okay, part B, the region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis has this area. Find the volume of the solid. Well, we know to get the volume of cross-section, we're going to do volume equals. It's since we're on the x-axis, it's going to be an x value to an x value, so it will be 0 to 2. We usually have to do a side trip to get the area, but they nicely gave me the area. Wasn't that kind of them? So I know that's my area, and then I'm pretty much set to do the problem. Since I am not getting to use my calculator, the first thing that I'm going to do, I notice that I have sign and then parentheses, so I'm going to let u be pi over 2x, which means du is going to be pi over 2. Notice I'm missing a pi over 2 on the inside, so I will put a 2 over pi on the outside. So now I'm going to have 2 over pi and sine of u, and then the antiderivative of sine of u is negative cosine u, but I do have the 2 over pi there still, so now, excuse me, I'm going to have negative 2 over pi cosine of pi over 2x, and then I get to evaluate it at 0 and 2. So if I plug in 2, I'm going to get pi over 2 times 2 is just pi, so I'm going to get negative 2 over pi cosine pi minus, if I plug 0 in, pi over 2 times 0 is 0, I'll get negative 2 over pi cosine of 0. Alright, then I know that the cosine of pi is equal to negative 1, so negative 2 over pi times negative 1 will be 2 over pi, and then the cosine of 0 is 1, so minus negative 2 over pi will be plus 2 over pi, and 2 over pi plus 2 over pi is going to equal 4 over pi. So that would be the answer for part B. This was again worth 3 points. If you have the sine of pi over 2x inside, you get a point. If you have the correct integral, so you got negative 2 over pi cosine of pi over 2x, you get a point. And then if you have the right answer, you're going to get another point. Okay, part C I'm just going to go ahead and put up here, I think. Another solid has the same base. For this solid, the cross sections perpendicular to the y-axis are squares. Right, but do not evaluate an integral expression for the volume of the solid. So we're going to have volume equals. This time, we are perpendicular to the y-axis, so everything needs to be in terms of y. So instead of going from an x value to an x value, I'll go y value to a y value. So this is going to be 0 to 4. And then my area, I'm going to come over here and come down here and do a little side trip. The area is equal to the side squared. Remember, the sides are going this way this time. So to get the side, we're going to do right minus left. And then please remember, both equations do need to be in terms of y. So I'm going to come over here, y equals 2x. I'm going to solve that for x. So I'll get x equals y over 2. So that's one of the curves. And then if I had y equals x squared to solve that, we're going to square root it, and I'll get x equals the square root of y. I'm not going to put plus or minus this time because I notice I'm only in the first quadrant, so I definitely don't need the -1. Okay, so now I just need to figure out which one of those is the right side and which one of those is the left side. So the right side is the curve, so that's going to be the square root of y, minus the left side. The left side is the straight line, which is y over 2 squared. So now I just need to put that back up into my volume formula. So I'll have square root of y minus y over 2 squared dy, and I should be all set. So now this was again worth 3 points. We got 2 points for the correct part inside, so probably if you remember, did you put it in terms of y, did you square it, did you subtract them? So just kind of give yourself a point off for each little mistake that you made. So again, that was worth 2 points. And then if you have the limits going from 0 to 4 instead of 0 to 2, you got your third point on that problem.